Hello everyone, welcome back to Cambridge Guru. In the previous video, we discussed why the integral of 1 upon x has to be log x. We discussed two reasons. Number one was that since differential or derivative of log x is 1 upon x, hence 1 upon x integral has to be log x. As derivative and antiderivative means integral, these are opposite, right? Second reason that I gave you, which was given in a graphical manner, where I'd introduce the concept of a hyperbola. Not the concept of a hyperbola, I introduce you the curve hyperbola which obeys certain property. And that property is that if you scale the x coordinates, that means if lower limit and upper limit are 1 and 3, and you are scaling the x coordinates, means to, let us say you are doubling the x coordinate from 2 to 6, limits changes to 2 to 6, right? So this hyperbolic function, it follows one of the type 1 upon x. It follows a special property that this area remains unchanged no matter you scale the x coordinate up or down. Then I gave you the reason that this is a property of changing multiplication into addition or subtraction, right? That means there is only a single function which follows this property, which change multiplication into addition, and that has to be log x. Let us introduce. Now we have ample amount of reason, and third reason that I will give you today is that since, let us suppose that integral of 1 upon x is log x, right? And we will replace this log x with a function. Since this is a function, so let us call this y is equal to log x. If y is equal to ln x, let us replace this variable x and change it into the new variable y and see whether the integral satisfy the given condition, that supposing that y is equal to ln x. So if y is ln x, that means I can replace x as e raised to power y. This base of log will go to LHS, so e raised to power y. That means I need to find out the value of derivative dx also. So dx is e raised to power y dy. Okay, replacing these values of x as e raised to power y and dx as e raised to power y dy, my integral changes to 1 upon x is e raised to power y and dx is e raised to power y dy. That means integral now changes to just dy. So integral of dy is just y. And what is our y function? This y function is nothing but log x. This, okay, this y is log x. Hence, we can say that yes, by putting the variable back into the integral, we are able to solve this integral, right? So this is giving you output function y, which has to be log x. Okay, so now we have ample amount of reasons. We have discussed three reasons here that why 1 upon x integral dx has to be log x. And in integral in calculus, we use log with base e, which is called natural log, and it is written as log ln x. This is nothing but ln x is just log x with base e. Okay, so just remember this, the formula, and based on this formula, let us quickly evaluate this integral, which is a definite integral. And of course, we have to introduce plus c if it is indefinite. So if it has to be log x, so 1 upon 2 we can take outside, and this is 1 upon x dx, limits from 2 to 5. So this is 1 upon 2 log x, lower limit 2, upper limit 5. Okay, so this is 1 upon 2 ln 5 minus ln 2. Okay, that means this is half ln 5 minus ln 2 means log a upon log b is log a upon b. Log a minus log b is log a upon b. That means ln 5 over 2. You can again reduce this further, that this is half ln 2.5 or simply ln 2.5 square root. Okay, any way you can leave the answer. Now, next thing is that as we know that now the integral of 1 upon x dx is log x plus c. Since log x is defined only for positive values of x, that means 1 upon x dx here, is it necessary that the limits this 2 and 5 has to be positive? Let us analyze this. That extending, which is called the next topic, extending the domain for logarithmic integrals. As you can see in the given figure, the curve which is rectangular hyperbola, which is y is equal to 1 upon x, this is given, and its integral is log x that we have just defined. So as you can see here in the right hand part, I can show you this part. I'm calling this area as b. Why I'm introducing area? Because since you are finding out, since limits are there, so imposing the limits, lower and upper limits, will give you the area under the curve. So I'm calling this area between a and b as b, right? So that means area b has to be equal to integral of 1 upon x dx from lower limit, which is a, to upper limit b. Integral of 1 upon x dx is ln x. By introducing the limits, I can directly write this as ln b minus ln a. This is your equation number 1, means the value of area a, I'm called not a, area b, sorry. Okay, this is area b, which is ln b minus ln a. Now as you can see here, that a part of the curve also lies below the x-axis, or for negative values of x. And as you can see, this area A, now I am talking about this area A which is below the x-axis, this is a real area, right? This area exists. That means mathematically also there has to be some value, or this process of integration also holds for these values of, for the negative values of x. Right? So let us see whether mathematically also we can derive this, or we can apply this formula, right? So area A, I'm now writing, this is from lower limit minus b. As you can see, lower limit here is minus b, as minus b is lying towards left of minus a. So lower limit has to be minus b and upper limit has to be minus a of the function 1 upon x dx. Now changing this variable, because this x is negative, let us change this variable x to negative of u to change into positive function, because after all log will be determined, means we are using this modulus in terms of modulus, means we have to incorporate some negative values, right? And that concept that log is defined only for positive values, this is valid. This has to be satisfied. That's why we are changing this negative values to positive values by converting this x into some another variable which is negative of the original variable x. So changing x to minus u will give you value of dx as minus du. This is first thing. Second thing is that if you are changing the variable, if you are substituting, that means you have to change the limits also. So corresponding limits will also be changed, right? So if x is minus u, if x is minus b, u will be positive b, and if x is minus a, u will be plus a. So now we have area A, which is equal to integral of lower limit will change to from minus b to plus b, and minus a to plus a will be your upper limit, and minus u will give you 1 upon x will be minus 1 upon u, and dx will be minus du. So this will automatically convert it to positive values. Why? Because minus sign of this du and minus sign of this u will get cancelled out. So you will get 1 upon u du. Right? Now you can easily integrate this. This will be log of a minus log of b. Upper limit is a, lower limit is minus b, and this is nothing but taking the minus sign outside. You can write this as minus ln b minus ln a, okay, which is negative of area b. So now what we have here is the equation that area A is equal to minus area B, right? So what you can observe here is that magnitude wise both the areas here are equal. The magnitude of A, magnitude of B, these are equal, only the difference lies in the sign. And this negative sign also has one explanation. This negative sign also has one explanation, that since this area A lies below x-axis, so what we have learned in the previous you can say class, means at the AS level, that if the integral value, definite integral value is coming out to be negative, that means that area has to be below x-axis. So since here A was below x-axis, that's why our area is coming out to be negative of the area which is lying above the x-axis. So area A is equal to minus times area B. That means this is a real area and it is coming out to be negative. This also has to be incorporated by converting the value of x as minus u. That means negative values will again be multiplied to negative sign to make it positive. So what we have here is that integral of 1 upon x dx has to be log of mod x, just to incorporate negative values of x, right? Because this will give you some real area. Okay, otherwise if there is an indefinite integral, you can just directly write as log x. Okay, most of the time we do not write this log mod x, but mathematically this fact has to be remembered, that exactly this has to be log of mod x. Now, since now we have learned that negative values are also incorporated in the domain, let us quickly understand the next part of this integration is if we generalize any function of the type 1 upon ax plus b instead of just 1 upon x. So if you have been given any linear function in the denominator of the type ax plus b, by writing this ax plus b to another variable t, okay, let us derive this. Let us say you have to integrate 1 upon ax plus b dx. Okay, so let us substitute, let ax plus b is another variable t. So a times dx will be equal to dt. Writing dx as dt by a means dx is dt over a. So this integral will now be converted into integral of 1 upon ax plus b is 1 upon t and dx value is dt over a, where a is a constant. If this is a constant, you can take this outside and it is just dt over t, which is nothing but 1 upon a log of ax plus b, means ln t, and replace the variable back to ax plus b, you will get log of ax plus b plus c, right? So in general, if you have a function of 1 upon ax plus b, you just write 1 upon log of ax plus b, but divide that with the coefficient of x. Okay, I think this we have learned in our integration when we would learn the integration of exponential function of the type ax plus b. Okay, so we need to divide whatever the integral, the basic integral, by the coefficient of x, and this is only possible if there is a linear function in the denominator. Okay, suppose for example integral of 1 upon 2x minus 3 dx, you can directly write this as 1 upon 2 ln of 2x minus 3 plus c. Okay, dividing by the coefficient of x and just writing the log of that function, that linear factor. Okay, so this is given like this. Okay, so evaluate this. You can quickly write this, that this has to be 1 upon 5 log of 5x plus 3, writing down the lower limit as 2, upper limit as 0, upper limit as 2, This is 1 upon 5 ln 10 plus 3 is 13 minus ln 0 plus 3 is ln 3. So ln 13 minus ln 3 is 1 upon 5 log of ln 13 by 3 plus, no need to write plus c because this is a definite integral, limits are there. Okay. Now, this graph is given to us. The diagram illustrates the graph of y is equal to e raised to power x. The point A has coordinates ln 5 comma 0. This is our point A. This point is A. Its coordinates are ln 5. This length is ln 5 and y coordinate has to be 0 on the x-axis. B has the coordinates ln 5 comma 5 and C has coordinates 0 comma 5. So this length is 5. This length is x. Find the area of the region OABE. O, A, B and E. This area means unshaded part we have to find out. Enclosed by the curve y is equal to e raised to power x, the x-axis, the y-axis and the line AB, this part. Okay. Hence, find the area of the shaded region EBC. EBC. Okay. This area, hence we have to find out. Okay.